Solving circuits, series and parallel. In this lesson, we're talking about circuit types and symbols review, measuring current and voltage. We're going to review circuits, switches, and then we're going to do some practice. So first, let's start off by reviewing the circuit types. So we have two different kinds of circuits. We have series circuits and we have parallel circuits. The difference between them is the number of branches that they have. Series circuits is one loop, whereas a parallel circuit has more than one loop. Now the symbols that we covered as well include the cell, so that's going to be a large line followed by a small line. The light bulb, which when I draw it, I typically draw it just an X. Sometimes you'll see it drawn more like this kind of shape, but I typically just draw it as an X. A voltmeter, an ammeter. Wire is just going to be a straight line using a ruler. A light switch is going to be this switch you can see here. And sometimes you'll see it drawn something like this, where it's actually connected. So this would be a closed switch right there, and this would be an open switch right there. A resistor or load, and then a battery. A battery is simply going to be two or more cells. You can see one cell here, right, this guy here, and then the second cell right there. Measuring current. Electric current is measured in amps using an ammeter. Ammeters are connected in series, that's between the wires inside the circuit. And we draw an ammeter like this in our schematic diagrams. So you're going to have your diagrams. Let's just say we have a light bulb, and then we want to measure the current through that area. We would draw a line, we would draw an A, and then we would draw another line like that. So you can see how it's inside the circuit. If we were to finish it off, maybe something like this, where you can see the ammeters within the circuit itself. And again, this is how they look inside a circuit. So you can see the ammeter is actually inside, whether it's a series circuit or a parallel circuit. Now, what is current? Well, current is the flow of electricity around a circuit, and it's going to run from positive to negative. And this is a little bit counterintuitive. So if this is our circuit here, that's going to be our negative, that's our positive. So our current is going to run from positive to negative, like that. Whereas the electrons actually flow the other way. Electrons are going to flow negative to positive. But when we talk about current, it's from positive to negative. And current is the amount of electrons passing a given point in 1 second. It's kind of like those turnstiles that you go through when you go to an event. It counts how many people are going into the event. Well, if you had a turnstile in the middle of a wire that counted the number of electrons that pass that given turnstile every second, that would be a measure of current. And that's what the ammeters do. They measure the number of electrons passing in a given amount of time. Measuring current. Current is the same at all points in the circuit. The current is the number of electrons passing a given point at any time. And each electron will continue to follow the single path all the way around until it gets back to the cell. So if you have, let's just use 2 electrons instead of 2 amps. Makes it easier to think about it. So if you have 2 electrons, they're going to leave the battery and they're going to travel all along this path. So it doesn't matter what part of the path that you look at it, that you peek in to see how many electrons are passing every given second, there's going to be 2. Measuring current. Current is shared between components. It is the number of electrons passing a given point each second. If 2 electrons come through a divider in a path, one will go one way while the other goes the other. Each path will get an equal number of electrons. So again, if we go back to our 2 electron idea, and we go back to our series circuit, you can see that there's only one path for the electrons to take. So those 2 electrons are going to follow that path all the way around. But if we have a parallel circuit, and we have 2 electrons leaving the battery, well, you're going to have 1 electron go this way, as represented by the 1 amp, and you're going to have 1 electron go in the other path, because they're going to pick their side, and they're going to divide up equally. If there were 3 paths, you get your 3 electrons divided by 3 different paths. Measuring current. When the paths come back together, the numbers will combine again. Therefore, the current at the start will equal the current at the end. And how do we measure current? Well, we use an ammeter or a multimeter. This is an example of a multimeter. A multimeter, as its name would imply, can measure different things. So it can measure amps, it can measure volts. So back to our example, if we have 2 electrons leaving the battery, one goes in the first path and one goes in the second path. Well, we still have one here and one here. And when they come together, there's 2 electrons again. And then it goes back up to the battery. So I want you to pause the video and I want you to fill in the missing ammeter readings for our series and our parallel circuits. Okay, you got your answer? Let's have a look. So let's start with the series circuit here on the left. We're told that there are 4 amps right here at this first point right here. So and since the series circuit, every point along the circuit is going to have 4 amps. So we're going to have 4 amps there and 4 amps there. In our parallel circuit on the right, we're going to have 3 amps, so 3 of this group of electrons. Remember, it's not actually 3 electrons, it's like 3 packages of electrons passing every second. So you have your 3 amps leaving the battery. You're going to have 1 amp go this way, 1 amp go this way, and 1 amp go that way. Now in these very basic circuits, we're always going to divide up our current evenly between the 3 branches. Now when they come back up here, all 3 branches are going to join again, and again we're going to have 3 amps. Potential difference, otherwise known as voltage. Now voltage is how much energy each electron has within the circuit, and it's called potential difference or voltage. It's called potential energy because it has the potential to do work if something is present to take the energy away. For example, when a charge flows through a flashlight bulb, it enters with a certain amount of energy and exits with less because the light bulb takes some away to light up, similar to paying for something. So if you think about our circuit, each electron is going to leave the battery with a certain amount of voltage. Let's call it 3 volts. Now if there are 2 places that it's going to use those voltage evenly, say a light bulb here and a light bulb there, this one electron is going to give 1.5 volts here, and it's only going to have 1.5 volts to give to this guy, and it's going to come back with 0. And that's good, because the potential difference across the battery is 3 volts, because every time the electron or group of electrons pass the point in the battery, it's going to give it that same charge. So this is how batteries run out of energy. Eventually they've given all their energy to the electrons passing through, and it has no more energy to give, and then you need to get a new battery or recharge it. So since we're calculating energy loss between one point and another, potential difference can only be calculated between 2 points. So you can't put your voltmeter in between here like this. That doesn't work. You need to actually set it up across the area like we have here. So our voltmeter, you can see, starts here at this point. So we connect it at point 1. We put it around this component, and we attach it here at point 2, around this light bulb here. Measuring voltage. The energy given to each electron is called the voltage. Voltage is measured in volts using a voltmeter. It can also be measured using a multimeter as well. Voltmeters are connected in parallel around the object. Measuring voltage. This is how we draw a voltmeter in a circuit. So you can see we're going to draw it from one point, up, over, and then back to another point across the thing we're measuring. We could draw it across the cell here by doing something like this. And you can see in the parallel circuit it's exactly the same. Series circuit. Voltage is shared between the components inside a series circuit. Each electron is given a certain amount of energy to start its voltage. If it gives half of its energy to the first bulb, it will only have half to give to the second bulb. So again, we're going to get 3 volts. Our electron is going to pass by. It's going to give 1.5 volts to the first bulb, and then it's only going to have 1.5 volts left to give to the second bulb. When it gets up here, it's going to have 0 volts. And that's great, because when it gets to the battery, that battery is going to give it 3 more volts, and it's going to leave the battery with 3 volts again. Parallel circuits are a little different. You've got to keep in mind that the voltage is the amount of energy each electron has. So as our electron leaves the battery, it has 3 volts. As it goes down this way, it's either going to go on our first path, where it will still have 3 volts, or it will go down to our second path, where again, it will have 3 volts. It's not losing anything when it goes down one path or the other. It's like if you have $10 in your pocket and there's 2 ways to go. If you take the first route or the second route, you're still going to have $10 in your pocket. So same idea. So whichever way the electron goes, it has 3 volts to give. So if it goes down this first path, it's going to have 3 volts to give to this bulb. And if it goes down the second path, it's going to have 3 volts to give to this bulb. This is different from the current, where current is the number of electrons. So if there's 4 electrons, 2 will go down the first path, 2 will go down the second path. But each of those electrons will still have the exact same voltage that they started with at the beginning. So since each electron is given a certain amount of energy by the battery, the amount of energy they can give doesn't depend on their route. Measuring current and voltage. So I want you to pause the video and determine the missing current and voltage readings. Okay, let's take a look at the answer. So each electron that leaves the battery has 6 volts. 6 volts. This is a series circuit, so each electron will pass through all the components until it makes its way back to the battery. That means that voltage that it has is going to be shared between every component. Now there's only 2 components, so it's going to give 3 volts here and 3 volts here. Now the amperage is a little bit different. We need to know how many electrons there are in the circuit. Now we can find that by looking at the end. You can see at the end we're told that there are 4 amps. If there are 4 amps at the end, there must have been 4 amps at the beginning, and there must have been 4 amps in the middle. So we've solved our circuit. Okay, once again, I want you to pause the video, and I want you to solve this circuit for the missing current and voltage. Okay, let's take a look. So we're told again that each electron leaving the battery has 6 volts of energy. Each electron is either going to go down this first path with 6 volts, or it's going to go down this second path with 6 volts. So if it goes down this first path, it's going to give all 6 of its volts to this light bulb, since it only has to share its voltage across one actual component. And when it comes back up here, it's going to have 0 volts left. The second path has electrons that again have 6 volts. So it's going to give all 6 volts to this bulb right here. Now for the current, we're told that there are 4 amps at the end. That means there must have been 4 amps at the beginning. Now, if there's 4 amps, that's 4 groups. That means 2 of the groups went down this way, so 2 amps, and 2 of the groups went down this way, 2 amps. And then when they came back up to meet each other, they added up to 4 again. Now, there's a couple other diagrams you need to be aware of when you're drawing circuit diagrams. We have our motor, which is going to be our circle with our M, and we have our fuse, which is going to be this little squiggly line. Circuits review. A circuit is a continuous loop where electricity can flow. A circuit is made out of an energy source, so a battery or plugging into the wall, etc., connecting wires, usually copper, an electrical device called a load, so a toaster, a light bulb, etc., a switch, such as a light switch, and all these things need to be in place for the circuit to function. Switches. So this diagram here represents an open switch. You can see that it's open because this part is not actually connected to the circuit. Now, switches are anything that connects the circuit into a loop. This circuit is not connected into a loop because there's a break in the circuit. If the switch is open, like we have here, the circuit is not complete. The electrons can't flow past and the light will be off. Now, a switch doesn't always have to be like a light switch. This here is an open switch. You can see that if we have components coming in on the left-hand side, like this, and we have wires going out the other side, like that, they're not going to be connected because these two guys right here are not connected to each other. Now, if the switch is closed, like we have in this bottom picture, the circuit is complete because electrons can flow past and the light will be on because the wire will come in here, the electricity will flow up there, here, and go back out the other side. So the circuit is complete. So what I'd like you to do now is pause the video and complete this chart. This chart asks you to compare series and parallel circuits in terms of paths, voltage, and current, whether they're shared or not shared. Now here are the answers. So make sure you double check what you did. If you didn't get them right, go back in the video and double check why you didn't get them right. And that concludes our lesson on solving series and parallel circuits.